Dear students, let's begin our basic science class. Firstly, revise the points that we have studied earlier. Okay, there are different types of motions taking place around us. Force and motion are connected each other. We need force to start a motion, to stop a motion, to change the direction of motion, to change the speed of motion. Then we discussed about 5 types of motion. These are the 5 types of motion. That is, the first one, motion through a straight line. So we call it as linear motion. Example, motion of a lift. The second one, motion of objects around its own axis. We call it as rotation. Rotation of a top is an example for rotational motion. Then the third one, motion along a circular path. We call it as circular motion. Examples are motion of the leaves of a fan. The fourth one, to and fro motion about a mean position, is called oscillation. Example is motion of a swing. The fifth and last one is vibration. Fastest oscillation are referred to as vibration. Example, motion of a stretched rubber band. So we understand about 5 types of motion. So let's perform our first activity. Activity number 1. Complete the table in page number 52 of your basic science textbook. Repeat. Complete the table in page number 52 of your basic science textbook. There is an error in the textbook. The diaphragm of Chanda is an example for vibration, but in textbook it is done as oscillation. It is not oscillation. It is a fastest oscillation, so it can be termed as vibration. Okay. Now, observe the picture. Did you see this arrangement before? Where did you see this? Yes, it's a part of a cycle. It's a part of a bicycle. Right. We know that we give force to the pedal. But where did the power felt or the pressure felt? Or where did the motion starts? Yes, the motion takes place at the wheels. Who carried this force to the wheels? Who carried this force from the pedal to the wheels? You can observe it is a chain that connects the pedal with the wheel. Okay, so in this, the force applied can be carried to another part where the motion takes place. There are a number of such familiar instances. Did you visit a flour mill? A flour mill helps us to powder the grains such as rice, wheat, etc. In a mill, you can see wheels of different sizes connected with belt. This belt helps to connect more wheels and move them. In the sewing machine, you can see this arrangement again to connect the large wheel with small wheel. We can see this arrangement in every automobiles, including the toys. How it works? It carries the force from the engine to the required parts. We call it as wheel and axle. So chain, belt, wheel and axle help us to carry the force from one point to another point and thus enable the motion. Observe the picture. You can find two wheels which rotates opposite to each other. This is called a gear. We know that adjacent wheels rotates in opposite direction. So it enables us to change the direction of motion. There are differences in the size of the wheels. So the speed can be increased or decreased. When the large wheel completes a single rotation, the small wheel may complete a 10 rotation. The teeth-like structure at the outer region helps to rotate the gear. Likewise, let's rotate more than one part by using gears. Let's go to the next activity, that is activity number 2. List out the arrangements which helps to carry force from one point to another. Draw the diagram of gears. I repeat, list out the arrangements which help to carry force from one point to another. Draw the diagram of gears. The second one, try to build the toy fan in page number 52 and gears in page number 53 of our basic science class. So you should have to build at least two items, that is toy fan depicted in page number 52 and gears in the page number 53 of our basic science textbook. And the third question completes the activities in the let us assess portion of the last part of this chapter. Okay, so now this chapter is over. On the next day we can make a test paper, so be prepared for it and do the activities. Okay.